Very good evening to all the listeners. Myself, Pranav Dixit, research scholar, SRMIST, New Delhi, India. First of all, I would like to thank IJEECS to accept my paper for publication. I am here to present my video recording for the presentation of the paper titled Optimal Distribution of Cultivated Land to Vegetable Crops Having Ambiguous Profits by Using Multi-Objective Fuzzy Linear Programming. Uh, for better understanding, I will take the help of PowerPoint presentation. So I am sharing the screen that would make the presentation more clear. So I think it is visible. This is my topic. Optimal distribution of cultivated land to vegetable crops having ambitious profits by using multi-objective fuzzy linear programming. And authors are myself, Pranav Dixit, and my research supervisor, SOHAN TYAGI. Now, abstract. While we all know that agriculture is a stream having many uncertainties. So decision in this field are driven by methodical planning to increase yields for the fulfill the needs of overwhelming population of the worldwide peoples. It also, on the other hand, we also need farmers to prosper and maximize their profit so that they could achieve higher profit. So in this paper, we have make some developments for the optimization of farmers profit, and we have used max mean approach and also used the optimization software TORA. So these are the keywords involved in the paper: fuzzy multi-objective linear programming, max mean approach, land distribution, weighted averages, and TORA. First is introduction. As all we know, economic model's ability to maximize the profit in the market is determines its success. So there is a substantial relationship between the yield generated by agriculture farms and demand of the product. So the primary aim of the farmer is that the vegetable crop which is being cultivated gives the maximum profit and maximum weighted annual returns. So there are many aspects while we discuss the farming: soil quality, crop rotation, climate conditions, market demand, irrigations. These are the factors and many more factors. So market prices are often impacted by several variables, including consumer and farmer sentiments, and financial planning is very useful. So it is extremely important to development and economic and fuzzy economic model so that it can ensure the best return and minimize the risk for the farmers. So there is a uncertainty involved. So we used fuzzy model for to handle the situation. So these are the literature review, and these are the contributions made in literature review, and it can be seen in the research paper in reference section. And this is the objective of our study, to produce at least best weighted return for the vegetable crops, and the uncertainty of earning owing to several factors. So, to include uncertainty in planning model using the proposed fungicide-based quadratic technique, also we have given a numerical example to understand the model solvability. And the technique, first of all, we will describe the problem. So let there be n producible crops and their profit being the K1, KI1, KI2, KI3, and KIN with their associated probability Pi, P1, P2, Pn with respect to KI1, KI2, and KIN. Now we introduce the variables xj, tj, and wj, which indicates the cultivation area, labor hours, and water units. So since land constraint is limited, let's say it's A. Labor hours are also limited. Let's call them T, and water resources are limited. And we also determine that a certain profit P, the minimum profit, is preserved. So this problem constitutes the linear programming problem like this. Land constraint less than equal to a, x1 plus x2 plus x3 plus xn. This is the cultivated land for the n crops. And the labor constraint, let for each, let the full time be t, we divide it into n parts, t1, t2, t3, tn, so that their linear combination is less than t. Similarly for the water constraint, and this is the profit constraints. So what we have used in this paper is a max-min approach. Very firstly, it was used by Zimmerman. He gave the max-min approach, which is very much used in the fuzzy logic. So what it says, consider the objective function. We have to optimize this function subjected to given constraint. So what it says, that when we go to fudgification, then we have to use some membership function, let's say mu1, mu2, mu3, mu_n with respect to the our constraints. So we choose the minimum of those membership functions. So the problem reduces to maximize of that minimum of mu dx, and that value we assume it, let it be alpha, minimum of all the membership functions. So what is alpha? So we have to maximize the minimum of mu rx, yeah, maximum of alpha, because we have taken alpha as the minimum of mu rx. So now we will understand this problem by a numerical example. So what is the numerical example? A farmer intended to cultivate a variety of vegetables. Like we have taken three crops: potato, tomato, and brinjal, and onion, 4 crops in fact. In a particular season, he has 25 acres of land, and he has 450 labor hours and 50 acres of water accessible. So this is the table in which all the information is given. And this is the profit for each crop with their respective probability. So 40% probability is that from brinjal he will get 74,000 rupees profit, from potato for 67,000, from onion 1,44,000, with tomato 1,98,000, and with 25% probability, these figures are mentioned in the table. With 20% probability, these figures are, and with 15% probability, means these are the chances of profit with this probability. 40% probability of getting this one, this much profit, 25% probability of that much profit, and 20% of this much profit, and so on, 15% of this much profit. And we have labor for brinjal is available 27 hours, potato for 18 hours, onion for 19 hours, and tomato for 20 hours. Also, water per acre available 1.8 unit, 1.3 unit, 1.7 unit, 1.84 units. Now, what we have done, we have, in order to solve it, by using this information, we converted into linear programming. One second. So these are the linear programming. Subjective to a constraint, we have three constraints: land restriction, labor restriction, water restriction. These are the four objective function with different probability. As we shown in the table, it has 40% probability, it has 30%, it has 25%, it has 15%. Now, the detailed description of working procedure of max-min principle is given in the research paper, which includes 6 or 7 steps. First of all, we have taken a membership function, increasing membership function, which will fudgify these equation into this crisp value into fuzzy value, and then by maximum we will defudgification. So after that we will get positive ideal solutions. These are the solution. We have obtained it by applying TORA software for optimization techniques. Then these are the positive ideal solution. Now what we will do, we will apply max-min principle. Full procedure is given in the research paper, so I am just taking the key points here. Then we will maximize the alpha. What is the alpha? It was obtained from here. Max-min. We have taken the maximum of Z1, Z2, Z3, Z4, and then we found them the maximum and minimum, then max minus mean value. Max minus mean value. Maximum value minus minimum value. This is in the last column. So it will constitute the, again, system of linear programming. And after using the software TORA, we found the solution of the different values x1, x2, x3, x4, and also the value of alpha 0.5. We got the value of alpha is 0.5. After that, we got our solutions like in previously we have shown x1 equal to 0, x2 equal to 0. This one after solving x3 this, x4 11.25 alpha, and this. And using these values, we found the value of this constraint 1 this, constraint 2 this, constraint 3 this, and Z1, Z2, Z3, Z4, all the values. So we have 4 optimization functions, Z1, Z2, Z3, Z4. We got the values, return calculation, and with different probability. Now, weighted average. Weighted average means we cannot be sure that always we will have that much profit, maximum profit, or that much profit. So for the best scenario, we have taken the weighted averages. Weighted average is calculated 43.39. So now, result and discussion. Crop output maximization does not guarantee profit maximization. So, if a farmer maximize its crop production, that necessarily not he will get the maximum profit. It requires the probabilistic and effective tackling of the different scenarios and different allocation of land and vegetable, and use its resources properly to maximize the profit. So fuzzy can be useful in this type of problems. So we have the 4 objectives. So our final result is he had to cultivate tomato at 11.84 acres land, and sorry, onion in 11.84 acres land, and tomato on 11.25 acres land. And his guaranteed average net earning will be 4.339 lakhs. And maximum profit will be, it's a 49 lakh, which will be only 49.92 lakhs, which will be in 15% of times. And minimum will be 39.32 lakhs at 40% of probability. So, but weighted average is 43.9. So, based on various profit coefficient probabilities, the study yields several ideal results. So, as a future perspective, it can be used effectively in optimizing resource management, crop yield production, and in different areas like pest and disease management, adaptive irrigation system, and policymakers can use fuzzy max min state methodology to develop policies for progress. So, conclusion remark. So, the quantitative techniques based on fuzzy sets that have been created may include uncertainty in planning model. Also, we have taken a numerical example to understand the max min technique, and this can be very potential application and need for the farmer to take right decision at right time. And fuzzy, these are the references. Actually, there are about 30 references. I cannot, uh, it will take many slides to one. So I have given some few references. Thank you. Thank you very much. Thanks a lot. Now I'm stop sharing.